Good afternoon, class. My name is Jinjin Zhai. Today, my group will conduct an oral presentation for assignment 2, covering these topics on the slide. Apple is one of the largest multinational technology companies in the world. It currently has approximately 4,000 employees across Australia and New Zealand. Apple has opened 22 stores across Australia. The store at Cheston has been one of the busiest since the grand opening. On average, 3,500 customers were served by Cheston's Apple's 240 employees before the COVID. Apple, as a highly respected technology company, desires a sophisticated scheduling system to meet its growing business needs and serve an increasing number of customers in a cost-effective way. Scheduling optimization poses a challenge to Apple's considering multiple constraints are involved in the model formulation. The optimization methods we suggest focuses on 32 employees, include both part-time and full-time from Apple's 5 roles within the sales department. Apple categorized its sales representatives into 5 kinds of roles: specialist, expert, operations expert, business expert, and a business pro. These roles differ in seniorities and skills. In order to achieve higher working efficiency and better support, multi-skilled full-time employees substitute for roles of business pro and business expert. I will now pass to Jianshu to summarize the literature review.
Thank you, Junjun. Our team reviewed relevant literature regarding shift scheduling. Based on Apple Cheston scenario, we summarized key strengths and limitations from the literature before developing staff scheduling model for Apple Cheston. Most models adopt integer programming and consider full-time and part-time employees. Constraints such as maximum working hours, duration of each shift, and break time are also considered under Australian labor law and other labor regulations. While taking these strengths into consideration, our group tries to avoid the following limitations from the literature. We avoid treating roles and skills as homogeneous, as Apple Store has 5 different roles at Cheston branch. We also avoid ignoring staff preference, which is closely related with staff retention rate. Now, Yaji will introduce our programming model for shift scheduling.
A binary integer programming model analyzing all constraints is applied for the Apple Store at Cheston. On a regular business day, Apple Cheston is assumed to open at 9 a.m. and close at 6 p.m. There are 3 shifts a day, shift A, B, C. Each shift is 3 hours long. The hourly wage of each role is collected from Glassdoor. Factors that may cause differences among employees are not considered, such as work experience. The BIP model sets decision variables as binary values. If the staff I is assigned to the shift J, the decision variable xij is 1, otherwise xij is 0. The objective function is to minimize labor cost Z, which equals to the sum of the 3 hours wages of all the employees in all the shifts. Multiple constraints are considered in the model. First, the position demand table shows the number of employees needed based on the on-site visit and interview of a Chinese Apple Store with similar circumstances. 2. To comply with Australian National Employment Standards, full-time employees must work 2 shifts a day, while part-time ones must work at most 1 shift a day. Third, multi-skilled employees work the mandatorily assigned tasks without individual preferences being considered. 4. Full-time employees' preferences are taken into consideration when assigning shifts. Employee number 1 doesn't want to work in shift A, then X1A is constrained to be 0. 5. To better serve customers, there must be at least 1 full-time employee working in each shift to provide in-time guidance. 6. Full-time employees must perform 2 consecutive shifts, either shift A and B or B and C. 7. The decision variables must be non-negative. Now I'll pass to Jiayuan to show us a live demo of the implementation of our model.
Now I am going to present the implementation in Excel Solver. Firstly, these are the hourly wages for different positions, including part-time and full-time. This table shows the decision variables that specify which shift will be allocated to each employee. The objective function is the total employee costs per day. It is the sum product of the above table multiplied by 3, as 1 shift has 3 working hours. The first constraint is the total number of employees should be greater than the position demand for each shift. For the working shifts, the full-time employee must have 2 shifts in one day, while the part-time would be allocated at the most 1 shift per day. Besides, the shifts for full-time employee should be continuous, so we set the shift B to 1. Moreover, we specify that at least 1 full-time specialist and expert should be on duty for each shift. After it, we click on the solver function to set the objective of minimizing the employee costs and set the shift arrangements as the changing variables. We also consider the employee preferences by setting the required shift to 0. We also set the decision variable as binary and non-negative. By clicking Solve, we could have the result. These are the final outcome. As we use BIP, Excel won't generate sensitivity analysis, so we manually change some constraints to assess its optimality. We firstly test the employee preferences and find out scheduling for a specialist is more flexible than the business expert, as they have part-time staff. Then we adjust the position demand and find that decreasing demand could reduce costs on part-time employees, but higher demand would not be met in this model. Now I will pass to Ron.
Our model has some strengths in developing Apple-Justin's optimal schedule solution. First, consider employees' preferences. Most of previous articles did not take employees' preferences into consideration. Our model considers that it will be a key factor to improve both employee and customer satisfaction because it could encourage employees to perform the task in a more efficient manner and contributes more effect and enthusiasm to serve the customers. Second, consider different demand during different periods in one day. In reality, the customer demand always changes in different periods. Therefore, the model must meet this condition of changing demand to ensure better solution. Third, heterogeneity of contract type, 5 roles, and multi-skill employees. This model fully considers all factors of the contract, including the contract type and the staff roles, which increase the accuracy and elasticity of this model. Meanwhile, this model considers multi-skill employees, which could provide more flexibility of scheduling. On the other hand, the weaknesses include the limitation of BIP, insufficient consideration regarding relevant constraints, unresponsive to disruption and emergencies, and the last one, limit referential value for Apple at Charleston because lacking of key information. Last part, suggestion and conclusion. Based on comprehensive consideration, some suggestions are developed. First, provide more combination of shifts. The current scheduling method contains 3 shifts of a working day and it only offers 2 scheduling options for full-time employees. It could be more agile by breaking down shift further, such as to 2-hour or 1-hour shift. Increase the number of casual employees. Current roster does not include any casual employees, but increase the number of casual employees. Apple at Charleston could respond to unexpected scheduling changes more effectively. Third, model as a baseline to modify store scheduling solution. Instead of simply adopting the output of the model, managers are suggested to adjust the roster based on real-world situations. Fourth, optimizing staff scheduling through demand forecasting. Management should record the staff demand on both daily and weekly basis to forecast the demand and optimize the staff scheduling. In conclusion, by implementing this model step by step, Apple is able to achieve optimal solution and reduce the cost.
Here is our reference list, and thanks for listening.